Welcome to this video. I'm HasPhysics and today we are going to be going over Newton's laws of motion. So first we are going to be going over Newton's first law, where it states that an object will stay in the same motion unless a resultant force is acting on the object. If there is no resultant force, then the object will remain stationary or in a constant velocity. Newton's second law states F equals ma, where F equals force, m equals mass, and a equals acceleration. Acceleration is directly proportional to the net force acting on it, and acceleration is also inversely proportional to its mass. Acceleration will be in the direction of the net force. So Newton's third law states that for every action there is an equal and opposite force of the same magnitude but in opposite directions. An example is that if a man is pushing a wall, the wall is pushing the man as well. So now we are going to be going on to our GCSE example. The first part I, which of these is the correct equation that relates force, mass, and acceleration? So we know from Newton's second law, F equals ma. This can also be written as F equals mass times acceleration. And which one does that match? That matches C. So C is going to be correct. Part II states that a cyclist has a mass of 70 kilograms. Calculate the force needed to accelerate the cyclist at 2 meters per second squared. State the unit. So we need to use the formula that we have over here. And so as we have the mass and the acceleration, we just need to multiply the mass by the acceleration, which is 70 multiplied by 2. And when you do that, we get 140. And as it is a force, the unit for force is newtons. So you just need to write newtons over here. So 140 and newtons. Now we are going to be going on to our A-level example, exam style question. A passenger is standing in a train. The train accelerates and he falls backwards. Use Newton's first law of motion to explain why he falls backwards. So Newton's first law states that that a resultant force of 0 will give a constant velocity. The friction between the floor and his feet causes an acceleration. And so the top half of the man has no resultant force as the train accelerates, causing him to fall backwards. And that is part A done. Now for part B. As the train leaves the next station, the passenger holds onto a vertical support as the train accelerates. This prevents the passenger falling backwards. With reference to Newton's laws of motion, explain why holding onto a vertical support prevents the passenger falling backwards. So the man pulls on the support, and so the support pulls on the man due to Newton's third law. This force is a resultant force on the man, making him accelerate with the same acceleration as the train due to Newton's first and second law. So the first part will be 2 marks and the second part will be 3 marks, and that's 5 marks altogether. And that's the question done. Thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.